Part 3 of Ionic nomenclature. This round we're going to be dealing with the polyatomics. The main ones that we focus on are the oxyanions. So let's do the worst of them first, the halogens. The only ones we need to deal with are chlorine, bromine, and iodine. Fluorine does not make polyatomic anything. For example purposes, as we've said, things in a group act the same. So we don't need to do all of them. They're not all going to be different. The only difference is which element I'm going to use, whether it's chlorine, bromine, or iodine. So let's just use chlorine for our example. The first thing you need to get down, ite means there are less oxygens. Ate means there are more oxygens. Let's start with the ite and ate of chlorine. The chlorite ion has 2 oxygens, chlorate has 3. Each has a negative charge. Chlorite has less oxygens than chlorate, which has more. Just like that. Done. Easy. But halogen oxyanions tend to have prefixes because you can have even fewer or even more oxygens. They're the only ones that you have to worry about doing this. We have to deal with those. I can have one less oxygen than ClO2-, or I can have one more oxygen than the chlorate ion. So I need something to denote that. So I use the prefix hypo to indicate that there are fewer, or per to indicate that there are more. Not like hyper, but just per. So I end up with the hypochlorite ion, the chlorite ion, chlorate, and perchlorate ions. And like I said, all the halogens work the same. So the only difference is whether you have chlorine, bromine, or iodine. But the formulas, the charges, everything stays the same, even the naming convention. The 2 tricky parts are knowing how many oxygens or what the charge is going to be. So how do we predict the charge? So let's do that. We'll start with the easy ones. All of these take on the charge you would expect them to take on if there were no oxygens involved. So for example, the sulfide ion you would expect to be sulfur with a -2 charge, just like we have already dealt with. If you stick oxygens on sulfur, it makes no difference. It changes the charge none whatsoever. You just end up with a 2 charge. And that holds true for all of these in the box. Add oxygens all day long, the charge stays the same. Number of oxygens is irrelevant. But do watch your endings. IDE means there is no oxygen. ITE or ATE means there are oxygens involved. Then there's these guys. Boron, carbon, and nitrogen. They're the only tricky ones you have to deal with because they treat oxygen like it's a noble gas. Oxygen's attached to them, that's what we work with. So nitrogen by itself, you would anticipate a -3 charge, and that's indeed what it does. Nitrite and nitrate, now that there's oxygen involved, the charge is based off of how close they are to oxygen. So they only take on a -1. They're 1 away from oxygen. Carbon would take on a -2 if you add oxygens, and boron would take on a -3 if you add oxygens. So what about the oxygens? How do you know how many there are? Because obviously there's been different amounts for the ITE and the ATE. So let's look at that. These follow a very simplistic principle. 2 oxygens is ite, 3 oxygens is ate. The end. If you have 2 oxygens, they have an ITE ending. If you have 3 oxygens, they have an ATE ending. On the other hand, those in the blue box, 3 oxygens is ITE, 4 oxygens is ATE. The majority of your periodic table is going to work with 3 and 4, but those that from boron to nitrogen and chlorine to iodine, those 6, 2 and 3 are your ite and your ate endings. Otherwise, they work exactly the same. So you figured out the charge is generally based on where they are. Now you know the oxygen is also based on where they are. There's more to it than that, but that's as far as we're going to talk about at this point. Finally, as far as your oxyanions are concerned, you will also have to deal with chromium and manganese. Chromium makes 2 ions that you need to be familiar with. The chromate ion, CrO4 2-, or the dichromate ion, Cr2O7, 2-. Manganese acts very similarly to a halogen. If you notice, it's also in a group 7. So MnO4 with a negative charge acts just like ClO4 with a negative charge, and you give it the name permanganate. So it's the permanganate ion. Beyond that, you have a few other polyatomics that you have to deal with. These are just special cases, things you need to know, such as peroxide ion, or the cyanide ion, ammonium ion, which we'll talk about covalents such as ammonia later. So be familiar with those and be prepared. Good luck.